Okay, so last time we had stopped just short of um, getting the schematic all finished. And so just as a quick refresher, we have a USB multiplexer to allow me to use the same USB hub on multiple computers. So we have a voltage input, USB, micro USB, a voltage regulator, take that 5 volts, 3.3 volts, our main USB connector for the hub, and then our multiplexer that can support up to 4 computers, and then 2 switches to allow us to give a 2-bit binary to the multiplexer to select which computer. So that should be straightforward enough. So I guess next step, now that we've presumably completed our schematic, would be to move on to creating a circuit board. A little bit of nomenclature here. We often are inclined to call what we're about to make a PCB. That's like colloquially correct. It's more accurately a PWB. PCB stands for printed circuit board. And without components applied to it, there's not much of circuitry going on. So technically what we're making is a printed wiring board. And then in industry, when you apply parts to it, it is called a circuit card assembly, or CCA, instead of a PCB. So just fun nomenclature for you. So we're going to right click on the project, add a new PCB document. And I'm actually going to save this as the same name as my schematic. So this is going to have the highly creative name of sheet 1. And that just makes life easier for importing the changes and such. So a few important things we're going to do before anything else. You see we get this lovely black rectangle that shows up. We're going to go to set our rules up. And we go to design rules. It brings up this window here. And there's a bunch of stuff you can mess with. A few important ones are clearance. So you'll see that all of these are currently set to 10. And this is like if I had, a footprint for a device next to another footprint for a device, or a trace or something like that. This is how close is the computer allowed to let them get to each other before it yells at you. You can see an example here where it has a via here and then a trace here, and it's saying what is the minimum clearance we can have, and that would be the distance between this via and this trace. And for our purposes, and the manufacturers we use, it is safe to set all of, and I do mean all of these numbers, to 6. And by the way, this dimension is in mils. If you don't, and that's not millimeters, okay? Mils, I guess I don't know where that name comes from, but that is 1/1000th of an inch, okay? So, and mils are something you will likely deal a lot with in circuit cards. For example, take your standard breadboard spacing. That's 100 mils. It's and 2.54 millimeters. It's 100 mils is what is it? 0.1 inches, a tenth of an inch. So yeah, that's what a mil is. And here we're defining this number as 6 mil. That's kind of the standard unit. So we might mess with clearance. We have our trace widths. These are all set to 10 by default. 10, unless you're dealing with really fine circuitry, 10 is a pretty safe number. In our case, for this board, 10 is fine. For most of your boards, 10 will be fine. And then, so we might set that as our min and our preferred width. Max width, I'm just going to pick something 15 and 15. That's for the top layer and the bottom layer. And then routing vias, this is all super exciting stuff. But a good via hole preferred would be, well, we have to set the minimum as well. I do 10 and 20. So, on the hole size, I do 10. And on the diameter, I do 20, and then I do that as my preferred. Okay. And there's a bunch of other rules that you'll come across. Anybody have any questions about rules? There's a lot of.
I actually have a question. It's not on the rules themselves, but so mine is set to mm. How do I change it to mil? I've tried like inputting it manually like there, but it doesn't let me.
So good question. Let's find something that has dimension on it. You see right here where it says board size and it says it in mil. You can change the program default and see how I just changed it to millimeter. All I hit was the Q key, like the letter Q, as in question. You can get to that also. Let me try to remember tools, maybe. There it is. View, and then toggle units, and you can see that Q key right there.
Okay, awesome. Thank you.
So yeah, that's pretty useful. And Altium is really cool about letting you switch back and forth between units. Like say you want to do the whole board in mils, but you have a requirement to put your mounting holes at 10 millimeters apart or whatever. You can switch back. And actually, while we're on the subject of dimensions, I'll bring up the grid. If you can get to this from the view grids thing. You can hit the letter G once, and this is just a snap grid. It helps you align your parts, and so you can select any of these, or you can hit the G key twice, and you can set a custom grid. And again, that's just for helping you align parts and things like that. So like, for instance, I mentioned that standard breadboard layout is 100 mil. So if I'm putting down pins that need to line up with a breadboard or something, I might temporarily set my grid to 100 mil. And that way I'm confident that all the pins I place are 100 mil apart, and then I can go back to whatever grid I was on. Okay. Okay. So what else do we need to do for setup? I think we're good to go on setup. I'm gonna go ahead and save it. And then I'm gonna design, import. Let's see if it yells at me for anything. When it says, well, I'll leave the room in, but just know that I'm going to show you what a room is. You can uncheck it whenever you do this process. I find them irritating. But I'm going to leave it in so I can show you what it is. Validate. Everybody's happy. Execute. And then off to the side, it'll pull in all your parts. That was, by the way, design import changes from the PCB project. And so all of our parts came in, and this red thing is a room. And it's really just an organizational thing, as far as I can tell, to help, like especially if I have more than one schematic page, it becomes, obvious. But the annoying thing about it is if I take anything off the room, it turns green, and green is bad in Altium. And so I always just delete it. But so anytime I do a design import change, I always uncheck the room because I find them irritating. Something else we can do immediately while we're here is these designators like J6 here and R5, R4. These are too big in my opinion. I find a good standard size is 30 mil text height. You can see that over here, 30 mil and 5 mil for stroke width. So what you can do, rather than going through and doing them one at a time, like I could just go change it right here. I can click on it, right click. There's a find similar objects. And then I'm not going to mess with anything. I'm just going to hit OK, and it'll select all the text. And I don't really care about these little ones. They don't matter to me. So I'm going to change them too. And you just 30 and 5. And then there we go. And one other setting. Actually, this one's a pretty important one. I always tell people to do this. Do I want to wait to show this? No, I'm going to show it now. Preferences, and then it'll pull up this. And there's Okay, well, when it shows up by default, this box won't be checked under polygon rebuild, this top box. I always recommend checking that box. I find it irritating to not have it. And basically, when we go on to do polygons later, anytime you make a change, they don't update automatically. This makes them update automatically. And maybe that'll make more sense later. But um, that makes life much simpler just to check that little box there. Okay. So let me pull this over here so I can look at it. Okay. So we're not going to lay out the entire board. I'm just going to go through some basic stuff you need to know. So remember from the last lesson, I talked about the 1, 2, and 3 keys. So 3 takes us into 3D view. I can zoom in. I can hit the shift key and right click hold, and we can move around. We got some pretty cool models here. And if I hit the 0 key, it goes back to like a flat view. So I can go to a crazy view, hit 0, it goes to flat. And then I can go back to 2D or edit mode, and I can go to 1, which is, I don't remember what they call it, but basically board edit mode. And so in the 1 screen, I can go to design, edit board shape, and I can easily change the board shape. So now when I go back to 2, I have a new shaped board. And then there's some crazy board shapes you can do. I'm not going to go over them in this video, but if you go, I believe Roseanne sent out the link to my other playlist on YouTube. If you go look at those videos in that, I make a really goofy shaped board for the sake of making a goofy shaped board. And so if you need to make anything other than a rectangle / square, go check that out. Okay. So we're just going to put a few parts down. So I guess a few important things. Again, spacebar moves things 90 degrees. So remember what I talked about capacitor needing to be close to the power pin. So so we might put that guy right there. I'm sorry, that's not the right capacitor. Hang on. C2 maybe? Or is it C3? Probably C3. So we might put this guy real close, nice and close. And then we might, so Control W. And then I don't like that size. If we look off to the side, we can see it's a width. I'm going to hit the tab key. We can see it's a width of 15. I don't like that. So I'm going to hit, not 2, the 3 key, sorry. And that will go through the different sizes I set up in my design rules. So I'm going to go to 10. And then I will connect that. And that's just showing you that we're going to make it nice and close like that. And then another thing is we're going to set up, so we're going to make a 2-layer board. You could make a 4-layer board. All you'd have to do is go to design, layer stack manager, wait for it to load. Oh, there it is. And you can just add more layers here. I'm not going to, but you can. I recommend adding signal layers. You can add plane layers. They confuse me. if you learn how to use them, more power to you. I'm already an old man stuck in my ways. So so we're making a 2-layer board, and it's always we typically will make the bottom layer a dedicated ground layer. And I guess it's worth noting, just because you dedicate a layer to, in this case, ground, does not mean you can't run traces through it. You still can. But as far as power is concerned, we would dedicate the whole layer to ground. So we're going to select the bottom layer because that's where we're going to put our ground plane. And then we're going to select this polygon tool here. And we're going to immediately hit the tab key. And that's, again, going to pause the program. We go over to net. We're going to select ground. Okay. And then I always make my ground plane the entire size of the board. So you just go to each corner in this case, and you can make these any shape you want. I mean, you can see I could make this a really crazy shape. But for this application, we're just going to make it a rectangle. And so I'm going to right click once and again and click out of it. And so now our entire bottom layer is a ground polygon. And what's cool about that, let me go back to the top layer, is like, see this ground here? How am I going to get that to ground? I mean, I guess I could run a trace to the connector where power comes in. Maybe it comes in here. But what's actually a lot easier and actually highly recommended is we instead just do this, and you can hit the number 2 key to pull up a via, and boom, and you can see that crosshair showed up. That means it's connected to ground now. So that didn't need to be complicated. What's a few other things? So I think what I might do, I could sit here and bore you with going through routing this entire thing. I'm not sure how helpful that would be. Um, well, I'll show you one thing. So I always joke with teams that I like for unless you're a project advisor or whoever says no, I don't understand why they do, but sometimes they do. Um, always put your name on the board. Um, always put your team name, always put the name of the board. Always put the version number, especially put the version number. But yeah, put your name on your board. I mean, I don't think any reason not to. I think it's a good thing. And if your teammates have been nice to you, then maybe think about putting their names. Um, and so, but you can have a little fun if you have some time. You can have a little fun with the making kind of a logo, not just for your team. You can do that, but also for the board itself, for like the board name. And so for this one, if you go to place and graphics, and then you kind of just select an area. um, Let me go find documents, and then this is USB mux. And you can see it pop up there. Oh, well, I meant for that to, oopsie, I meant for that to be on the top layer. My bad. No. Okay. I meant for that to be on top overlay. Top overlay is, if I click the 3, you've seen this before. It's where it's like the silk screen. It shows up often white on a circuit board. It's printed on there. So that's what that is. It's the same layer these designators are on. So yeah, you can see that. That looks pretty cool. You know, it's spiced it up a little. So if you have time, that's always fun to do. You can put your team logo in exactly the same way. So I think what I'm going to show you is this, and we'll just kind of talk through it for a second. So a few things going on here. All these are our micro USB. We can click the 3 real quick and you can see them. All these are our micro USB connectors, and they have big ground connections and all that. And so what I've done is this whole red polygon here is one big ground polygon. And then because it's not the primary ground connection, remember we made this polygon on the bottom to be that, I've put a bunch of vias, whole ton of vias, to connect this top layer polygon to a lower layer polygon. And again, if you have any questions at any point, please butt in. And let's see what else. And so here I have this micro USB is where power comes in. And so what I've done is I've created a polygon that connects to the regulator, and then it goes down and carries power over to this USB-A connector, which delivers power to my peripherals. Let's see. And then this is the regulator itself. I would do one thing different. I typically tell teams that anytime you're dealing with a power signal, to not use a trace. And here I've violated my own rule. I did a 3.3 volt trace. I made a Y, which is sad. And then, but what I could have done and probably should do is I should create a polygon that's kind of a goofy shape. It kind of goes around this pad, down here, around here, up and around here. And because we set those clearance constraints earlier, Altium won't let 2 polygons interfere with each other. In fact, you can see 2 different polygons. If I can get it to click. No. Click on it. Maybe. There it is. Okay. So there's one, and you can see it extends all the way into here, technically. And then there's another one, and you can see Altium did not allow them to interfere with each other because we set up those clearance constraints earlier. So yeah. Here I've gone, I've used a via to go under this trace and come back up, and that's fine. No big deal there. This is my capstone logo. I've added 2 mounting holes just in case I decide to design a case for this or something. I don't know. I mean, you guys tell me. There's 2 of you in here. What are you thinking? How you feeling? Got any questions? How we doing?
I'm wondering how you did the mounting holes. Are they just vias or?
Yeah, so you could do that a number of ways. Let's see. Yeah, I'd probably put in a via. Of course, we set via constraints earlier, so I might put a pad instead. And then to be honest with you, I don't know what the difference is. And then you can just mess with the size in the properties here. These I designed to accept a M2.5. So if you don't, I don't know how you if y'all know your thread sizes, but that's a metric 2.5, and that generally means that it'll have a 2.5 millimeter diameter. So these I've probably, let me hit the Q key. Yeah, I've made them 2.7, so that way it can easily fit 2.5 through with a little bit of wiggle room. Yeah, I mean, this is a very simple board. If you're dealing in slightly higher frequencies, like let's say I2C or something, you might avoid as many of these layer jumps like I did right here. You might avoid as many of those as possible just for signal well, non-degradation. I can't think of the word. I mean, there's a bunch of like just little tidbits and stuff. Yeah, there's not much to this one. Pretty simple board. What are how complex are y'all's 2 projects?
Mine is kind of basically what you're doing. I only have a voltage regulator, a couple of USBs, and I do have some external connections that I need to figure out how I'm going to do. I'm thinking about using screw terminals.
Okay.
But that's pretty much it for me.
Cool. Yeah, screw terminals are a good choice. Yeah. Cool. So I guess if we're good here, I don't know what else to say about this. I mean, we didn't design any of the footprint that, I mean, we already did that. It's just a matter of placing them. When you're placing a capacitor, you want it to be close to the device it's associated with. Resistors aren't such a big deal as far as closeness. We want to plan things, so you can see how I've managed to get. Let me turn off the blue layer. It's distracting. So you can see how I've managed to do most of these without doing layer jumps. I had to do a few, but for the most part, no layer jumps. Didn't have to do it here. Managed to go around. That's good. The more of that, the better. But yeah, unfortunately, when on Altium, if we go back to this one, I mean, you can see these are called air wires, air like the air you breathe. And once all of those are gone, that means you've succeeded. So that's just showing a connection yet to be made. But yeah, so let's go to, if we're good there, I'm going to put bottom layer back. Oh, and I do want to emphasize the importance again of clearance constraints. Where they go? So I had a team last semester who, oops, let me go back to, who had somehow managed to accidentally set one of these, the whole one's not what I'm talking about, but one of the other ones to 0. And I don't remember which one it was, but I want to say it was via, well, I don't know. I don't know what it was, but what happened then, and they couldn't tell this until they ordered the board. What happened was that, let's say, let's take this via, for instance. It had no clearance constraint to the ground plane. And so this via, despite not being supposed to, was touching ground. There was no clearance here. Obviously, that's bad. And it took, I think, 3 different tries with professors to even figure out what the problem was. So those are pretty important. Pay attention to those. And they were delayed on ordering their board and all that good stuff. So yeah. So if we're good there, then what we're gonna do is save early, save often, and we are going to we're gonna do fabrication outputs. So are we good on layout? Like seriously, either you have questions, anything, because I'm just gonna move on to fabrication outputs if we're good.
I don't have any questions.
Okay, thank you. Okay, so file, you will be tempted to go to export. Don't. Go a little bit further and go to fabrication outputs. And then we will go to Gerber X2. Okay, and it'll pull up this window here. And there's 2 tabs here. Make sure you go to both of them and check everything. These are all the different layers. And by layers, I mean all these layers down here. And you want to make sure you get the drill files too. Drills being like when it drills the holes and all that stuff. So we'll do that and we'll hit OK and it will do some Altium magic. It will pop up this cam file. And now we do it again. So we go to file. Now we go to export. You would think this would be a simpler process, but it's not. And then click Gerber, just hit OK. And then it'll pop up this thing and you can tell it, you can give it a folder where to put it. And then you'd hit OK. I'm not going to do it again though. And so then you'll end up in your folder like this. Okay. And we have all the different Gerber files. And so what we'll do then is you will put that into a zipped folder. Whoops. Hang on. So like here, I've compressed it into a zip folder. And then just because that's what the manufacturer wants for reasons. I don't know. They wanted it in a zip folder. So I guess it uploads easier because it's compressed. But and then I like to use this company. They're Chinese. Like I mean, they're in China is what I mean. And but I've had good consistent quality with them. They make it really fast. They ship it really fast. Use whoever you want. These guys do good work and they go quick. So you just add it and it's got a pretty cool little process here. Once it uploads, it's absurd levels of cheap. So we're at quantity 5 for $2. And yes, that is $2. You can pick any color you want that they have. And what they do instead of charging you more for it is they make it take longer. So you get a pretty purple one, but it'll take 2 more days. Your choice. If you're ahead, then congratulations. I don't know if I'd mess with any of the other settings, except for maybe if you're dealing with a board that has a higher like power rating than something like what we've just done, then you might consider doing a 2 ounce. Note that increased the cost notably. Let's see if green brings it down. So $19 isn't bad. That just means it's more copper per square unit. 2 ounces instead of 1 in the same area. So you have more copper density and therefore higher current capacity. And then you just go order it. They have PayPal, they have all that kind of stuff. Roseanne's used them before, so all that's good. You can also get a stencil from them. And this is good for if you're doing finer type soldering. You just want to get solder paste and heat the whole thing up and make your life easier. So you can order a stencil. It's like $7. So even if you don't use it, you might throw it in for funsies. Yeah. So that's that. And that's our little board. A few other things, I guess I may have said this last time, but I always recommend over labeling if there is such a thing. So like if you had I2C components or something like that on the board, like you see how I've labeled this one power. I've been a little lazy with labeling on this one because I knew no one was going to use it except for me. By the way, I don't know if I mentioned this. You can see my mouse here. It's going through this board right now. It's off to the side. So it does work. um, but yeah, if you have like an I2C device or something, it's probably a good idea to put the address on the board. And just any useful information you have. I always like to say, give your software person as much information as they can handle, and then go ask them what other information they'd like to have on the board, and what kind of pinouts they want on the board. So, like if your software, like if you had, like I said, I2C lines, or something like that, you might put a little pin header, and you might break it out for your software guy or gal. So be extra considerate of their needs when you go to design and put all your extra connectoring on the board. It's more than just, you're thinking beyond just the basic parts you need to design the board and make it work. You're also thinking about how functional is it, and how troubleshootable is it, right? So test points, test points, test points. The more test points you can put on a board, the better. So test points can take any form. You can just put y'all are familiar with the pin header, the type of pins that match breadboard spacing. You could put if you had I2C lines, you could put like a 2-pin header and break out the I2C lines. And so you could, connect to them. You could do that. There's a bunch of other types of test points. You can define test point however you want. You could just put vias. That's fine as long as you label them. But test points, test points, test points. Put a lot of test points. I can't emphasize that enough. It will irritate the snot out of you if you don't, and then you have a problem where you can't probe something. Yep, I think that's it.
I just wanted to ask about, I guess it's more like aesthetic of the sheet that you create. You know how it has like title and then what else does it say? Like version company. Yes, that right there. I cannot figure out how to make it pretty, I guess.
So, well, do you know how to fill it out?
How did we? I think we did B1 or something, and then it was just a bunch of like gray fonts. Let me see.
Because to fill it out, you just go to the parameters under properties. But if you want to make it pretty, let me see if I have. Oh, it doesn't have. Dang it.
Did you have a logo on there?
I did, but this is a different computer, so it's not in the right spot.
Oh,
But
okay.
so this, what I did, you have to Google custom schematic template in Altium, because to be honest with you, I can't remember how to do it. I recommend B size, by the way. B as in boy. It's just a good size. It's nice and big. But anyway, so but yeah, you can open up a schematic template, the B size template, and basically you can mess with this in much more detail. And then when you save it in the correct location, you see how this says Gravitas B. That's my custom template. And it's alongside all the other standard templates. So so yeah, look up custom schematic template in Altium.
Okay.
And I think there was a video I watched. So hopefully you can find that. But yeah, I was able to put all kinds of fun stuff like revision and my who my sponsors and such were. I was able to put a logo, like you say, make it pretty. So
Yeah. Well, I don't really have any other questions.
okay. What about you, Alfonso? How you doing?
Um, oh, well, I just came here because I saw the email about it. I just got accepted to my major. I'm just learning about circuits. I just wanted to see what the type of stuff I'll be doing in the future.
Okay.
Yeah,
Well, hey, welcome.
yeah, thanks. Yeah, I don't really understand much what's going on, but I just want to see.
Well, maybe you'll remember something when it matters.
Yeah.
But yeah, these videos, if you did see the email, will be available on YouTube. I think
Oh,
Roseanne. Sorry.
where do you have a YouTube channel?
Yeah. Let me find it. I'll put it in the. Whoops, wrong thing. I'll go ahead and end the recording.